Good morning, this is Miss Goodwin, and today we are covering Objective 3.2, Rigid Transformations. The objective for today is that we can determine if two shapes are congruent using rigid transformations. So what is a rigid transformation, also known as an isometric transformation? This is a transformation in which the shape does not change size or angles. So it's going to look exactly the same. It might be flipped or turned a little, but we're going to talk about those kind of changes in a moment. So before, we need to discuss some vocabulary. So the pre-image and image are terms that we use for the shapes before and after. So the pre-image and image are what we call the shapes before and after. Pre-image is the before. So if, for example, we have this triangle here, that is our pre-image. Then we perform some transformation, in this case a translation. And now it's over here. That's what we call our image. Notice the slight difference in how we label it. So the pre-image has just A. So we just use a variable, typically a capital letter, to denote the pre-image. And then we add an apostrophe or prime to the letter to tell us that's the image after the transformation. So now let's look at the types of transformations. So the first one is translation, which is sliding. So this is simply moving the shape around. It maintains its orientation. There's no turning or flipping. So we have this triangle here, and I'm just going to slide it. And I'll use green for the image. See, so it's the top corner stays the top corner. The sides don't rotate or flip or anything. We just slit it. So this could be B and this would be B prime. Now let's say we're given the coordinates. We can write rules using the coordinates for our transformation. So let's say we move to the right. That means we're going to add something to our x coordinate, but keep the y the same. So the x increases, the y stays the same. Now let's say we move to the left. We decrease our x instead of increase and keep the y the same. Now let's say we move it up. We keep our x the same, but increase our y. Now h and k are just variables or stand-ins for numbers. So let's say we decrease or move down. I jumped ahead. We're moving down. We decrease our y, but keep the x the same. So just to reiterate, moving to the right increases x, moving to the left decreases x, moving up increases y, and moving down decreases y. And oops, some of it disappeared. There we go. Seems it's a little buggy today, but let's look at reflection. So reflection mirrors the shape across an axis. So for example, we have this little P here. We could flip it across the y-axis, or we could flip it across the x-axis. So let's say we are, nope. Sorry, I don't know why it's so buggy today. Let's say we are flipping across the x-axis. Then the x coordinate will actually stay the same, but the y coordinate will change signs. So if it's a positive, it turns to negative. If it's a negative, it turns to positive. Now if we flip it across the y-axis, it's the other way around. So the x changes signs, but the y stays the same. Now, let's say we want to flip it over the line y equals x. So that would be a line that goes like this. Then the coordinates are just going to switch places. So the x and y flip. Now let's do our last one. If we flip over y equals negative x, so that is going to be this line. Then the coordinates stay in the same place, but both of them change signs. So it becomes negative x, negative y. So those are the transformation rules for flipping an image or reflecting. We have one more. And this one's a little trickier. So now we're going to look at rotations. The rotation is turning the shape around the origin. Any point really, but we're going to focus on just the origin to make our lives simpler. So this will look like we have our image here. Could rotate it like this, or like this. It can either go clockwise or counterclockwise. So we're going to have a little bit of overlap in how we rotate. So let's say our transformation is 90 degrees clockwise or 270 counterclockwise. Then the coordinate xy will become y comma negative x. So we flip them and then change the sign on the second one. Now, let's say we do 180 degrees. Now, 180 degrees is the same both counterclockwise and clockwise. So for this one, the x and y are going to stay in the same location, but both of them are going to change signs. Our last one is 270 degrees clockwise, which is the same as the 90 degrees counterclockwise. The y and x are going to flip places, but the first coordinate, the y, becomes negative. And then excuse the last row there, we don't need that. So these are our rotation transformations. Let's look at a few example problems now. So we are asking ourselves what transformation took place. Let's look at this coordinate here. Let me label that x. X is at -1, 2. Let's label this y and this z. Alright, I've gone ahead and labeled all our coordinates on both shapes. And I found all the coordinates or vertices on the pre-image. So x is -1, 2, y is -3, 1, and z is -3, 4. Let's find the images of those. So x prime is going to be 1, -2. Y prime is going to be 3, -1. And z prime is 3, -4. So I noticed x and y stay in the same location. But change signs. So this could mean either 180-degree rotation or flip across y equals -x. So both of these have the same outcome, so both would be correct. Let's look at another example. Now we're given the coordinates and we want to figure out what transformation took place. I don't see anything staying the same, so I'm going to assume it's a translation. So I don't see 1 and 2 in the image. That's a good hint that you're dealing with translation, because with reflection and rotation, x and y are still going to be present in your image. They might change signs or be flipped, but you'll still see them. So this is likely a translation. Now we need to figure out exactly what transformed. So I have my image and pre-image. I flipped that, but whatever. I'm going to go ahead and take the image and subtract the pre-image, which gives me a 4. Positive 4. Then do the same with my y, so -4 minus 2. That gives me -6. 1 to 5, that's +4. 3 to 7, that's +4. So I know x, we're going to add 4 to that. And then let's check our y. 5 minus 6 gives us -1. 6 minus 6 gives us 0. So y minus 6 also works. And that is our translation rule. We went up 4 and down, or no, we went to the right 4 and down 6. Okay. Oop, now we are wanting to find our new coordinates if we flip the pre-image over the line x equals y. So remember, the rule looks like xy becomes yx. So we just flip our coordinates. So flip 3, 2, that becomes 2, 3. 4, 6 becomes 6, 4. 2, 6 becomes 2, 6. And 7, 8 becomes 8, 7. So that's it for that one. Let's look at 2 more. Now we want to start translating and actually transform our shape. So we want to translate our figure 3 units down and 2 units to the left. So that becomes x minus 2, and 3 units down is y minus 3. So let's start with this guy right here and go down 3. So 1, 2, 3. It's going to be right there to start. But now we have to go 2 units to the left. So 1, 2. That point is right there now. Then you would do this for every point. So let's put, whoopsie daisies, put another point right here. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. 1, 2, no, 1, 2, 3, 1, 2. Those are the coordinates of our shape, so we could just sketch it right here. And we got our shape translated. So this, let's say this is x, this would be x prime. So let's say we want to figure out what the point is. Our original point A is at 2, 2. A prime ends up at 0, negative 1. So if it's asking for coordinates, that's what it would look like. But we are done translating that shape. Let's look at the last problem real quick. Oop, now we want to find the general rule of the transformation that takes place. I've gone ahead and labeled my points. A is at negative 3, 3. A prime is at negative 3, negative 3. So it looks like we might have had a flip, or a rotation, I mean. Looks like these coordinates probably switched places, and then this one changed signs. The second one changed signs. So it looks like we may have had a rotation that was 90 degrees counterclockwise. Let's see if that holds true. So B is at negative 1, 3. B prime is at negative 3, negative 1. Yep, that still holds true. So we flipped our coordinates and changed the sign to a negative on the first one. Double check with C for good measure. C is negative 1, 2. C prime is negative 2, negative 1. Yep, that worked. So our transformation is a rotation 90 degrees counterclockwise, or you could say 270 clockwise. And that is it. So go ahead, summarize the notes, and get started on some of the practice problems, and I'll see you next time. Bye!